There is something I want to talk to you about after the class, of course. If I forget, please remind me. If I forget, please remind me. How are you? Okay, that's great. Today, I want us to talk about something that is very important, more than anything we've actually done so far. The one that I saw that you're going to get so many marks, right? Yesterday it was Monday, right? And then Monday we talked about some Cartesian plane that doesn't have x and y's, and so. Can you see this? Okay, thank you. Now that you have that Cartesian plane, we said that, okay, fair. If, let's say, we draw a circle, I'm going to try and make sure that my circle is, oh, this is bad. My writing is too bad. That is why I always avoid my handwriting and use slides instead. But these slides are making me too fast. Oh, you are agreeing that I'm too fast. So you are agreeing that we'll finish the syllabus. Yeah. So we said that we have a circle yesterday, and then we said, if you look at that point there, and you say that at that point you have 360 degrees, and you want to convert it to radians. What did we say that was? It was 2 pi radians, right? Now, If let's say you divide 360 by 2, what do you get? 180. So somewhere there, somewhere here is supposed to be, I'm going to just write here, 180 degrees. If you divide 2 pi by 2, what do you get? So you have a whole pi radians there. If you divide 180 by 2, what do you get? 90 is supposed to be somewhere there. And then if you divide pi by 2, what do you get? So you have a half a pi. You don't have the whole pi, half of it. And then if you divide pi by 2, pi over 2 by 2, what do you get? So your 45 degrees is the same as pi over 4. So we're saying that this thing is in radians. So we said that we dealt with that thing, right? And then most of you are familiar with this. They are saying that, say, that equation that you're writing there, which was nonsense, I don't like it, I have my own way. If I just want to change that 1 pi to be 108, is that okay? I said it's fine. That formula is not standardized. I'm just giving you an illustration of how you can go about it. It's not saying that it is a must that you must go that way. If you have a way that is going for you, fine. All of us here know maths. It's not like we have to follow a certain standard. One answers. Are you getting it? Yes, so that's what is important here. So today, I want us to realize that this point here is the origin. And then we just place an O there. You getting it? And then we say that, okay, I'm going to draw a line that goes there. And then I'm going to call that point B. Are you getting it? And then I draw a perpendicular line, that is a line coming from B, and then it forms a 90 degrees with this horizontal axis. Are you getting it? Do you get that this side is positive? Do you get that side it is positive? Do you get that this side is negative? Do you get that this side is negative? Okay. At least if you get that, you have passed the course. Now that we have that, I want us to recognize that this angle here is x. Let's just place an x here. Why are we using x instead of theta? It's because we want to have the independent variable to be x, and the variable that we are controlling, we are changing or we are turning to be x, so that when we are going to the original Cartesian plane of x and y. Are you getting it at the back? What is basically happening here, guys? When I'm sitting here, you are there. It looks like I'm looking here, but it's not the case. I'm not focusing here. I can see everyone who's up there. It's just that when you're up there, I'm so down there. You get what I mean? But I can see you when you're raising a hand. Now, what I'm saying, let's say this point is A. We're going to call it A, right? Now, I want us to focus on this triangle. Leave this whole thing as it is. Are you getting it? If we focus on this triangle, can you see that this is a right angled triangle? Because there is a 90 degrees. Can you see that this angle X is the angle that is marked in that triangle? Can you see that the side between X and 90 degrees is adjacent side? So the adjacent side is the same as OA. Can you see that? Origin up to A. And then the opposite side, it is AB. And then the hypotenuse is O? Okay, OB, not OA, guys. Now that we have that, what is sine of x? Remember that x is the given angle. Sine of x is AB over O. Sine is opposite over hypotenuse. So what is the hypotenuse? OB. Now, what I want us to do, I want this circle of ours to have a radius 1. Are you getting it? So that we have all the radiuses going out is 1. So if that is 1, this is going to be 1, right? This point here, what will be the value there? It's going to be 1. What will be the value there? 1. What will be the value there? Remember that this side is negative. So this is going to be minus 1. What will be the value there? Minus 1. So at least now we have something. My circle is not that great, guys, but I've tried. All of us here. I think I have a best circle here. But here's the thing, guys. We have sine. Now, what is the value of OB in that case? It's 1. So this is going to be equal to AB over 1 or AP. So take note that in this case, our sine of x is going to be AB. Copy it. That's what I want you to copy. It's very important. Yeah. Yes. So we have this nice thing there, sitting there. Did you copy it? You still copying? My class is good at copying. They want to copy everything. That's one thing that I know. And then, while you're copying that, let's look at cosine of x. We said cosine of x is the adjacent of, this is adjacent, guys, over hypotenuse, right? And then what is adjacent in the triangle there? OA divided by OB. What is OB? So you have OA divided by 1. Okay, fine. I want you to also copy cosine of x is the same as OA. Copy it, take it inside. And then, what is tan of x? Tan of x is the same as sine of x divided by cosine of x. Simple as that. That's just simple as that. And then what is sine of x? It's going to be AB divided by OA. And then this is going to be tan of x. And then you copy that. Now that you have that, what is cosecant of x? Cosec of x. Cosec. Cosecant. It's cosecant, right? Cosec. In full. It's cosec. Cosec. OA. You know these things. What about the cotangent of x? So the cotangent of x is this. So, or you can just call it cot, is the same as 1 over tan of x. What was tan? You copied it. It was. So what will this be? You just change the numerator and the denominator. It's going to be OA over AB. Copied that. Okay, let me see here if that is true. Where is cos? Cos is OA, so OA should be in the numerator. Okay, fine. Now, the question is, can we plot these things? Can we plot these things? I'm going to try and plot, let's say 2 or 3. and then the rest is your homework. Yeah, try and plot it. I'm just gonna plot sine of x, cosecant of x, give you an idea of tan of x, and then move on to something else. You getting it? I want you to get just little piece. One thing about my students, they always don't get anything. But if you give them something, but sir, this is how you solve it. But they say, I don't get it. But it's fine. Let's try and plot and see what we're going to get here. I'm gonna come here, and then I'm gonna draw something here, this side. I'm trying my best here, guys. This is not drawn into scale. And then here, what is 45 in radians? Remember that this now is going to be x and this is going to be y now, because we're plotting, we want to find the output. Okay, this is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. What is 45 degrees in radians? So it is a quarter of a pi, right? If you multiply that by 2, what are you going to get? Pi over a 2. If you multiply pi over 4 by 3, what are you going to get? 3 pi over a 4. If you multiply pi over 4 by 4, what do you get? Pi. If you multiply pi over 4 by 6, what do you get? Yes, 3 pi over a 2. If you multiply pi over 4 by 7, what do you get? 7 pi over a 4. If you multiply pi over 4 by 4, by 4, yes, what do you get? I mean by 8, not 7 now, by 8. It's going to be pi over 4 times 8. 8 divided by 4. 2 times pi. Yes, here we have 2 pi. Not 1 pi, but 2. And then this side, we're going to have the negative of these things. 1, 2, 3, 4, 5, 6, 7. So we have 1, 2, 3, 4, 5, 6, 7. So we have minus pi over 4, minus pi over 2, minus 3 pi over a 4, minus, come on guys, please help me here. Minus pi here, here, 7 pi over 4, and then here, thank you. Now we have that. I want us to mark 1 there. I'll tell you in a moment. We have 1, and then we have a minus 1 there. Now, I also want us to just place a dotted lines at 1 there, and dotted lines at minus 1. Try and make sure that your dotted lines are better than mine, guys. I want you to be better than me when it comes to maths. I don't want you to be less than me. If I'm a doctor, I want you to be a professor. You get what I mean? Yes. If I'm a professor, I want you to be, if God allows, to be an emeritus professor. You get what I mean? So this is how this thing. If I approach you and I go there, I want you to leave the academia and become the VC. But this is what is happening here. I am going to draw that unit circle there again, so that at least we can get clarity. I've tried. You can't blame me, I tried. It's just that this thing is not working well as it's supposed to be. Yeah. So this is going to be, I want a unit circle. Oh. Someone is hoping that I'm not supposed to get this right. But I'm gonna get it, don't worry. If I don't get it right now, class is dismissed. Yeah, this is good. So it's a unit circle because there you have a 1, here you have a 1, and here you have a minus 1, and there you have a minus 1. And we said this is not y and this one is not x, because x is revolving this way. Now, I said that we draw a point there, and this one is going to be RB, and then you draw a perpendicular thing, the perpendicular line, this is B, this is the origin, our X is there. This is our X there. Now, you know that sine of X is the same as AB. We want to analyze that AB. Let's forget about sine of 90, let's just analyze AB and see what we can get. Now, if you look at AB here, right? AB here. If I were to choose B to be here, what will be the value of AB? If I were to choose the value, B to be that point along the horizontal axis, this shaded point, this big point there, what will be the value of AB? It's going to be? No. AB is the height. What will be the height of AB? It's going to be louder. It's going to be 0 because if I have this, B will be there and A will be there. There will be 1 point, just a point. So there is no difference between A and B. So it's going to be 0. So 0 is there. Yes. Where's the hand? Yes. Okay. Let's start from the beginning. I said that we choose our random point to be on the circle B. So our point is going to be, I'm saying B was supposed to be here, so that we can draw AB and we can see it. Now, if I decide that my B is there, so that, let me write it here. You had this nice circle. You have the origin here. My B is there. This is going to be B. My A is there at that point. What will be the height between A and B? So, someone is saying not. I don't know what's the meaning of not. But one thing that I know is 0 is at the origin. Are you getting it? At the back. Okay, can you see there at the back? Okay, thank you. Now that we have that, I want us to pick a value somewhere there in the middle. Are you getting it? In other words, we pushed our x. Our x now is this angle here. And then this is our new B. This is our new A. Are you getting it? Now, looking at this height here and this new height, what has happened to the height of AB? Has it decreased or has it increased? Is it bigger than 1 or less than 1? It is? Yes, it is somewhere there. Right? Remember that one. I'm not trying to be accurate if possible, but we know that it is less than 1, but it is bigger than 0. But it has increased from that point. Are you getting it after this part? Okay. Now, I am choosing. This is still the same thing, but my B now, my new B is there. This is B, right? Can you see that? And now my new A is the perpendicular height to the x-axis. Because now it's, the horizontal axis. If you look at the vertical axis and the horizontal axis, the perpendicular height will lie on top of that. In other words, A will move to the origin. Can you see that? Yes. So our new A now is going to be here at the origin. What is the value of AB? Yes, here it is 1. Why are we there at the moment here? It's because we know that this value here is pi over 2. Are you seeing it a little bit? Okay. You're not getting it? Okay. Let's start from the beginning again. What I'm saying here, do you get that if we have this part here, which is B, do you get up to this part? Or you want us to keep moving until you get it? Change the color. Okay. Let me choose red. Red means that students are going to fail. Let me do something else. Blue. Blue is right? Yeah. Green. Okay, some green light. Oh, this is green. Not lime. Okay. I said, listen carefully. I'm going to start here. Can you see this one? I first drew that triangle. And I said, this is my B, right? So at this point here, we have our AB. So we have this little AB, which is the height. This is A, this is B. Are you getting it? Now, I am saying from that point, I want to choose a new B. This is my new B. I'm going to make it red because it's the one that you don't understand, right? That's a new B. So, moving from that point to that point is B, but I want to also draw a perpendicular height to the horizontal axis. And at that point there, I want to mark it as point A. Right, it is perpendicular. Are you getting it? Now, I have that thing here, which is the new A and B. Are you getting it? Now, the question is this new AB bigger than this AB, or is it less? It is bigger. So if it is bigger, looking at the diagram here, if we're somewhere here, we're supposed to get something that is a little bit above. Are you getting it up to this one? Yes. Now I am saying I am choosing a new B. Are you getting it? But now my new B will be blue, and then my new B will be here. Right. And then this new B, I draw the radius here. Right. And this radius, of course, is still 1. Now, because I had a triangle like this, and then now I moved a little bit, I got a triangle of this format. And now I moved a little bit, I got a triangle of this format. And now I moved until I am there. So this was A, and then it moved here, and then it moved there, and then now it is here. Can you get it up to this one? That A keep moving until it is at the origin. Yes, that's what is happening here. We have A is here at the origin, and then we have B there. I am asking you, what is the height of AB, this new height AB? Yes, this new height is this height here in the graph. That point. We want AB to be equal to 1. Yes, because of that. Now, I am choosing a new B to be here. We have a B there. This is not B, this is A. And of course, B is from the origin. In order for me to draw a perpendicular line to the horizontal axis are here. So that line needs to move from B up until you arrive down there, and it is perpendicular. And then where they meet, you're going to have your A. Are you getting it? Now, looking at this new height and the previous blue height, is this new height bigger than that or smaller than the previous height? So we are expecting a value to be somewhere below 1. Are you getting it? Is it less than 0 or bigger than 0? Is it above the axis is it above the horizontal axis or below? Above means positive. Are you getting it? Yes. Now that you have that, the point is supposed to be somewhere there. Are you getting it up to this one? Now, I am choosing my B to be here. This is my new B. Let me choose a different color here. Right. And now it's moving from the origin. What will happen to A? Where is A? A is also at the same point, because as that triangle is moving, take this as if I'm holding, where's this mouse now? Take this as if I'm holding this B here, and then as I am moving it here, it changes, and as I'm moving it here, A keep moving. It's like I have a string and then I keep moving it like this, and then A keeps moving. Are you seeing it? Yes. And then when we are here at this point, this new point, let me take a different color here. When we are in this point, our A and B, they meet there. There is no difference. Can you see there? What is the height now between A and B? So, which means that we are here. Are you getting it up to this one? Now, yes. You mean AB? You are saying it's supposed to be negative, or you are have the horizontal axis, and the height is moving this way. The height is moving this way. The height is moving this way. So if you look at the height when it is above the axis, is y above the axis positive or negative? Yes, so the height is positive. If we were looking for cosine, for instance, cosine is dealing with this side, the horizontal axis. So when we're in this side, OA is going to be positive, but when we're at this side, it's going to be negative. You get it? Yes. Now that we have this, I pick another point somewhere in the middle there, and I say this is going to be our new B, and then you have this, and then our A is that point there somewhere, and then we have a perpendicular point there, so we have an A there. Now I am asking, has the height from the previous height increased or decreased? It has. Those are saying decrease, raise your hand. Those that are saying increased, raise your hand. Those who are sleeping, raise your hand. If you are sleeping, please raise your hand. Yeah. The good thing about sleeping is that you can dream about it. In the exam, you always gonna think my grandma told me something last night. No, you are dreaming about the day you were in class and sleeping. Your grandma is still resting. So what is basically happening here, guys, both, all of you are actually correct, but it depends on the context here. The height is increasing in the negative direction, below the axis. If you are looking at the negative sign and 0, the negative is less than 0. So all of you are correct in some way. It depends how you explain it. So this height here is kind of increasing by below the axis. I'm getting it. So it was a dot and now it increased to the negative direction. So I'm going to get a negative or a positive. So it's going to be a negative because it's below the axis. Now the question is this height bigger than minus, is this height above -1 or below -1? It is. Where is -1 here? We have a -1 there. Is it above or below? So at this point here, it is still above. Can you see that? And then if we pick a point somewhere there, our B is here now. Let me choose a different color before you bite me. So you have a B there. Where will our A be? Okay, what is the height between A and B now? It's going to be, because our A is going to be at the origin. So here, we're going to have -1. And now if we keep picking, all you will end up seeing here, before you end up sleeping, guys, you will end up seeing something like this. Are you getting it? And then if you continue in this side, you will end up seeing something of this kind. Are you getting it? That's what's going to happen if you keep analyzing these points before you end up sleeping in my class. That's what's going to happen. Now, look, this is just a plot of AB. Our AB is the same as sine. So this is the plot of sine. Now, if you look into this curve, right? If you look into this curve, I want to point something important here, guys. Let's be serious. If you look at this plot, it's going up and down, right? Up and down. So it goes up, and then it arrives at 1, it goes down, down, and then it arrives at -1, and then it goes up. You're getting it? So it starts somewhere at 0 if you start at the origin. It's going to go all the way down, reaches 0, goes down, and then it goes back, and then it starts repeating what it was doing from 0. Are you getting it? So if you have a function of that kind, we say it is periodic. That's the meaning of periodic. It was doing this, and then it started to repeat what it was doing. Just a wave. You're getting it? So if it was going up, it goes up, goes up, goes up, and then it starts coming down, and then At some point, it starts doing what it was doing here, going up, 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 up. Are you seeing that? Let me put it like this. A periodic function is like this. You draw it from this point A to point B, and then above or beyond point B, it started doing what it was doing from point A. That's what it is doing. You plot it like this, and that's the meaning, the general meaning of periodic. I don't want to write the maths because it becomes even more confusing. But what is happening here is this. I want you to draw dotted lines when this function is equal to 0. Like vertical line, but in dotted lines. Let me use red instead. So I'm going to place these dotted lines there. I'm going to place these dotted lines there. I'm going to place these dotted lines along these y-axis. I'm going to place these dotted lines there. Why are we doing that? You'll find out in a moment. Okay. What is the domain of sine of x? Okay, what is the domain of that function? Okay, in general, guys, if you have sine of x, what is the domain? X is there any value that I can plug in sine such that I don't get a value? Which means x is the element of real numbers. But if there is no arrow there at this point and at that point, which means your domain starts at that point and end at that point. But if I place some arrow there and I place some arrow there, I mean this continues. You started straight lines, right? You said that the difference between a straight line and a line segment is that a line segment starts at one point and ends in another point. But when it comes to a straight line is going from this side and that side and it continues forever, right? So those arrows, they also mean the same thing here, that you are continuing. So in that case, the domain is, x is element of real numbers. What is the range? Y is an element of real numbers. Thank you. Are you arguing with a doctor, guys? Yeah. I'm telling you that range, x is an element of real numbers. Is it complete? So you are saying the range here is supposed to be y is an element of real numbers such that something happened. What is that thing? Negative 1 is less than or equal to y and y is less than or equal to 1. Is that what you're saying? Okay. At least I'm learning something from you guys. Okay, fair. Now that we have those points, we have the dotted lines. Can you realize that when sine is 0 there at that point, 1 over sine is undefined? Can you realize that? Okay. What I want us to deal with here, I want us to deal with cosec x. But it's easy to draw it if you know the shape of sine. It's going to make it this whole thing easy. So you're going to have, remember, you're not going to be having a calculator. Guys, if I decide to leave, let me make this a secret. If I decide to leave, maybe tomorrow or any other day, that condition, you're going to start the new conditions with the person who's coming. I'm just saying if that would happen. So if you are praying so hard that I leave so that you can get your calculator, you negotiate with the next person. Keep praying. Okay, now we have this whole thing here. The numerator is 1, guys. Numerator is 1. Right. At this point, this is equal to 1. We're going to start there, guys. We're going to start there. If sine of x is equal to 1, what will be the value of cosecant x? It's going to be 1 because sine is equal to 1. And this function here is sine of x and it was the same as AB. We're analyzing AB, but AB is the same as sine. Are you getting it? So, if sine of x is equal to 1, what about cosecant it is? What is 1 divided by 1? 1. Thank you. If I pick a point somewhere here, right, a point there, is that point less than or bigger than 1? Here. 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 If I pick this point here, lime point, lime. If I pick that point there, is that point bigger than 1 or less than 1? Is it bigger than 0 or less than 0? Now I have a fraction. Let's say that fraction is 1/2. If I take 1 and divide by 1/2, will I get a value that is below 1 or above 1? Let me repeat. If I pick a value that is between 1 and 0, because I want a value that I want to work with, that I can work with, I am picking 1/2, which is 0.5. Right. If I say 1 divided by 0.5 or divided by 1/2, will I get a value that's above 1 or below 1? So you are saying you're going to get a value that is, let me use a red here. You're going to get a value somewhere there if I divide 1 by that value. Remember, we're using this. If I pick another value here, what will I get? A value here on this. Can you see, guys? This is the point that I'm picking here. Where am I? I'm picking this point. I picked a point here, and then we have an output there. I pick a point here. What will be the output? Will the output be above or below? It will be? Yes. So in that case, you will end up having a point somewhere there. Right. So because this is undefined at this point, and you can see the curve is going this way and it's curving that way, because at this point here, you can see that the graph is going that way and this side is going that way. So how will this continue? It will continue. It's not going to touch this because at that point, sine of x is 0. So sine of 0 is? Sine of 0 is? What is 1 divided by 0? Yes. So this curve here is going to continue like this. And this is going to be your cosecant of x. Are you getting it up to this one? No. Did you get that we picked a value on the curve? We are picking a value of sine of x here. We are not picking the value of x here. We are picking the value of sine of x. Remember that here we have x. We plug it inside sine. We get an output. That output that we have is the one that we plug it inside 1/x to get cosecant of x. So now we are picking the output on the curve of sine. Are you getting it? So at this point, we started at this point and we picked a value on the curve. What is the value of the curve there? It's 1. And then we went back to this given function here. Let me just try and see. So basically here, we picked this point, right, on this orange curve, right? And then what's the value there? It is 1. And then we plug that value here as the output of sine of x. So we get 1/1. What is 1/1? That is why we have that red dot there. You getting it? And then from there, we decided, okay, fine, we already have that. We pick another point on the curve, but within this interval. The point that we picked was here, about half. That half is the value of sine of x, and then we plug it here. 1 divided by half, what is it? 2. Is 2 below 1 or above 1? It is somewhere above there. I'm getting it. So we placed another dot there. Because this value and that value are the same, which means if I plug the same value here, I will still get the same output. So this and that is there. And then I said, the shape of the curve is going to go like this from this point here. And then I picked another point here, just close here, on the curve. What is that point? 0,001. Are you getting it? Let's write it. Let's do some math. So I picked the point here, which is, where's this? Now I'm going to have 0, 0 space now. Let me just write here. 1 divided by 0,001. I pick that point. I want to find what is the value of 1 divided by 0,01. Can you work with the decimals? Can you work with the decimals? You can't. Let's remove the decimal. The comma is somewhere there. So I want to move it 1, 2, 3. So we multiply by 10 to the power 3. Right? Because we do not have 10 to the power 3 in the denominator, we do the same thing on the numerator. Right? What is 1 times 10 to the power 3? 1000 or 10 to the power 3. What is the answer here? 1. So you get 1000. Is 1000 below this point or above that point? So it is somewhere there. So it tells you that this curve is going to continue this way, and then this side is going to continue that way. Can you see it? That's what I was trying to explain here. And the same thing here is going to happen at this point. This was not correct. I was supposed to pass here. So you're supposed to get a nice curve like this here, and a nice curve like that there, and a nice curve like that there. That's how cosecant looks like. Are you getting it? It's not that hard. It's really not that hard. It's just me who's making this. This is supposed to look like this. Can you see it? Yes. Try and deal with cos and secant. Right? Just try and deal with that. Tomorrow we're just going to take a few minutes and just analyze. I'm not going to go through the same thing. The process is the same. Are you getting it? Thank you. We're going to analyze what is important tomorrow and go to exponential functions, and then we'll find